All right. The Revolutionary Phenotype. So a reminder, what is it? The Revolutionary Phenotype is my book. It is my most important scientific theory. I started thinking about this idea around the time I was a postdoc at Duke University. And I was so impressed by the idea, I said, all right, I'm not going to continue my research in universities. I believe that this idea is the most important thing I'm ever going to find. I consider that it will be one of the most important theoretical addition in biology since Charles Darwin. What does it say? The Revolutionary Phenotype explains a part of biology that we hadn't succeeded at explaining. This part is, why are there genetic codes? And it explains how the first replicator in a line of descent, the first time DNA showed up on Earth, it explains the circumstances in which these events occur. The selfish gene of Richard Dawkins, I consider, is an explanation of everything that happens after. So regular evolution, the replicators fight for their own survival. They become stronger and stronger. They become better at surviving, better at eliminating other replicators around them, etc.
Read your books.
All right, we're
It's not
live.
like he's. Oh, here we go.
Mid-sentence. Okay.
Mm.
Today we read The Revolutionary Phenotype by J.F. Gariepy. It took a little while. I struggled with the book. The prose takes some getting used to. It's very technical. But I finished it, and it was good. It was all right. I think it's definitely an interesting book in terms of the concept it explores. The prose definitely needs some work. But I think there's more than enough content to discuss sort of the idea it had. And it's mainly about sort of JF's pet theory about how, like, not really abiogenesis, but the how like DNA came to be, and then like how that relates to perhaps future methods of life for like our genetic replication, things like that. So it's pretty technical, and it also tries not to be technical. It tries to explain everything with analogies. I'm echoing a bit with you, Mo.
Oh shit! Hold on. Let me.
JF sucks. Oof. The book is alright. Yeah.
There, are we good?
Yeah. Less echoing. I don't think. Yeah, I think we're good now. Okay. So the prologue, he talks about he wants to warn humanity against a development pathway that will end. Yeah, you're still echoing. Epic.
God damn it! Epic start for the. Oh,
you can just use
okay. I'm gonna try and
or something like
that.
that.
I could. I'll do that.
Yeah,
Give me a few
it's
seconds.
not like you talk all that often. Dab dab.
Ha ha ha! Mo, speak your speech.
All right.
Push.
Anyways, he wants to. He figured out this sort of theory for why DNA came to be, and then started replicating in life forms. And then he sort of applied that to, okay, so what happens later down the line once we start using genetically modified human babies, using different systems of technology to modify ourselves. And he says that if we have a few things in addition to genetic modification, then it very quickly can spiral out of control and lead us to our own genetic modification overtaking us as the self-replicator, and us becoming like a slave organs to the sort of genetic modification technology, which is sort of the whole, what he aims to make as a plausible explanation throughout the book. And I found it pretty interesting, and I think he does a good job at explaining the different technical concepts.
It's definitely not completely out in the woods. It's pretty solid.
Yeah. All right. So what JF first describes is that instead of DNA just like spontaneously combining from proteins, there was RNA was like the first protein, and then RNA created DNA, and then DNA took over RNAs. The hypothesis he's going for early evolution of single-cell organisms. And he lays out a pretty compelling case for this in later chapters. The other thing he's trying to work on is a sort of more general theory for when something that is replicating is overtaken by its own creation. That's what he calls the phenotypic revolution. That's sort of the name of the theory for the book. And he then tries to apply the sort of the normal evolutionary methodologies, natural selection, to like gene editing technology, and see how that would eventually sort of play out, and how that would lead us to become sort of instinct or enslaved, like RNA is enslaved to DNA, and that's sort of his concern. All right, so part one, he starts basically giving you a little biology lesson, talks about how cells are just a variety of different machines, or I guess it's sort of his aesthetic arrangement of biology. So like cells are a variety of molecular machines created by DNA to complete various tasks to meet the goals of DNA. So that is to say, your body is, at least according to JF's sort of definitions, all of your body parts, your organs, your brain, all of it is just a vector, a machine that the DNA, the little coded DNA makes, and then you're supposed to push that forward. And that's it. Like basically all the complexity, all of the different things is simply so DNA can self-replicate, and nothing else is particularly, there's not like any higher purpose to it. It's all sort of aiming at the self-replication. And he basically says that we're ultimately slaves to DNA before anything else, that like every iota of us is created by this sort of DNA structure and then leads to the replication of DNA, which is an interesting way to look at it. He then says that DNA originally was a simple molecule that was used to aid in RNA reproduction. So RNA would have its genetic code and would copy stuff, but it wasn't that good at copying things, RNA. And so there was like a mutation that allowed it to form DNA proteins, which it then used to transfer its RNA genetics via DNA to the next generation of RNA.
Well, that theory, he comes in with two parts of theory, because there's the one where it's for its own good, and then he talks about the DNA being used as viruses to attack other organisms.
Well, the viruses are just sort of the leftovers of RNA organisms after DNA took over, and sort of, well, I guess we should preface this. So he's trying to describe the early, like pre-cell life situation. So there's like, imagine there's just like lukewarm ocean a few million years ago with the cloud cover and the primordial soup, as people call it, and then there's strands of proteins that form RNA. So there's these little protein strands that self-replicate, and they have the different arrangements. And there's RNA viruses and like self-replicating RNA, and they have like an arms race. Like the viruses are trying to latch onto the RNA and take them over, and then replicate the viruses and so on. So there's just these little RNA strands like battling each other, and then one of the RNA strands mutates and creates DNA in order to replicate itself. So the DNA is able to produce strands of RNA that are much more precisely and efficiently copied and produced. And so let's say an RNA strand makes a DNA strand, and then it makes like a ton of copies of RNA. And so that RNA makes more DNA to make more RNA, and so on. And so then you have this situation where there's these RNA, which is sort of the main life form that use these DNA to reproduce. And then the DNA eventually mutate to self-replicate themselves, and then they start using the RNA to self-replicate themselves instead of favoring replicating the RNA. And that's sort of the very basis of the book, is that this event way back when the DNA was originally, at least he theorizes, was a machine that RNA used to replicate faster and more. And eventually, as more DNAs were made, it self-selected to produce itself. Because obviously, if you're an RNA, then it would favor selection if you can have a self-replicating DNA, because the DNA would then make more RNAs of you. But what they didn't, not that the RNA has like consciousness, it's just strands of protein, but sort of like the selection of just like like pressure of quantity in the environment. So natural selection. natural selection pressures it, and eventually the self-replicating DNA says, okay, well, we got to produce more than the RNA because we don't benefit from the RNA, and so the DNA self-replicator that can replicate itself more favorably then starts overtaking the RNA in the environment. All right. And then he sort of has this whole analogy where he calls like the RNA the queens and the DNA is the servants, and they have like a French Revolution style overthrow. He tries to anthropomorphize it to try to make this sort of story about proteins interacting with each other in a statistical way, like interesting. Like it's not like these different entities have like consciousness and they're battling, and it's just sort of an analogy to try and make it readable. Basically, all that really occurred is that there's these self-replicating proteins, and that as statistics played out over time, DNA subsumed RNA and became the better self-replicating protein. Like that's it. It's just math, basically. All right. And then he goes on to use this to try and describe his definition for the phenotypic revolution. So that's when, let's say, you're a thing that is that replicates. So I guess us humans are replicatable things. Or you could say that our DNA is the only thing that replicates, and we're just vehicles for it. Either way, we replicate. And we can make other things that replicate, but most of the things that we make that replicate don't survive without us. Like memes, for example, is another big subject of the book. Is like memes do self-replicate, like they jump from mind to mind. But if there were no brains to think about memes, then the memes wouldn't exist anymore, or at least they wouldn't like reproduce anymore if there was nothing to hold them. Like yeah, we could all die and there might be some memes left on our hard drive, but if there's no one to read the memes, they don't really exist or produce, or nothing really happens with them. So it's not the same as the same.
Yeah, and that kind of plays into his naked.
Yeah, that comes a bit
theory later.
All right. So he sort of has this narrative where the DNA genome is a sort of, all right, so it's a sort of 6 billion coded combination of proteins that dictate the result, and the result is merely just a machine to levy more DNA into the environment. Like all of the complexity is simply like the DNA is basically an algorithm that says make more, and all of everything else is just a result of that. And he ultimately says that we are slaves to the sort of the will of DNA to self-replicate, or at least as a society, we are slaves to self-replication, and that's why memes don't rule us. Is because ultimately, if you have a meme that doesn't value self-replication, it's not going to survive. So all memes like inherently value self-replication. That's sort of his counterpoint to people who say like memes we were ruled by memes, and free will's a joke.
It only works to the extent that a meme helps with reproduction.
Yeah, so like the only memes that actually survive are or at least procreate to a large extent are memes that help reproduction to begin with. So like, for example, if you're an antinatalist, that meme's not going to become popular because all the antinatalists don't have kids and they die. So like over time, there's just not going to be a large number of antinatalists. All right. So yeah, he talks about memes in this chapter. Then he talks about how memes can't be independent, and yeah, that's the end of chapter 1. All right, so chapter 2, JF starts talking about the original model set out by Dawkins. So Dawkins basically made the not the academic, but sort of the pop science, the popularly understood way of like how the environment forces change onto these protein expressions, I guess. So the DNA expresses its cells, its multicellular organism in such a way to try to replicate more, and then the environment pressures that, and that affects the statistical outcome of the species. That's what natural selection is. It's just basically statistics. It's not some like weird process where where things are like there's some sort of like law of the jungle, and X dies, the Y lives. Like you don't need to do that. It's just like statistically the thing that produces more will be in higher quantity and persist through time. Like it's not like any sort of hyped up sort of deal. And he just sort of describes that for the reader, and then he talks about his sort of addendum to it, that the when you combine the sort of DNA replication process, which is sort of, the DNA just wants to reproduce itself, and then the body is just a vehicle for the DNA. And then you combine that with the environment, it is restrained and defined by both factors. So, like, for example, the things start, like a dung beetle rolls dung because that became a successful way to transmit the dung beetle, and the quantity of dung beetle is related to the amount of dung in the environment that can sustain dung beetle. And you can apply that to different niches, and eventually the reason like we became most successful is because we sort of transcended the niches using intelligence, so we can survive in like every niche, and so it doesn't matter with us. But if you look at all of like natural animals, they just like were selected by the environment, and they're attuned to their environment because that's what statistically persisted through time in that environment. Anyways, so the combination of the sort of imperfections in both the phenotypic machines and the replication itself. So there's tiny imperfections in the replication. DNA doesn't replicate perfectly. It replicates pretty good. It's like 1 in 10,000, or probably more than that. I think it was like 1 in 10 million.
Wasn't it 1 in 10 million?
Yeah, 1 in 10 million little data points, little proteins get done incorrectly when you account for all the repair stuff. And that just leads to the slight variations. And then just statistically over time, it will just, the things that have better variations will persist in their environments. And he sort of wants to make the distinction that your organs are not self-replicators. So they're a part of you, and they're like okay, so the DNA is making, like, you can make the argument, oh well, my liver is a self-replicator because my DNA makes me have a liver, and every time the DNA replicates, it makes a liver. So the liver is sort of like, are we all just building livers? Is that the point of everything? It's just we're all just carrying livers and then we replicate livers? No, because it doesn't, if you take a liver out of the body, it doesn't survive on its own, of course. It just sort of shrivels up and dies. And the liver itself doesn't have its own genetic code to pass on. I mean, the cells have different DNA, like the liver cells like can be cultured, of course, but it's not like they have the reproduction. The liver cells are not like reproducing to evolve to better liver cells alone in the environment. Like, they're not in an environment to be modified, and they don't have they're not independently evolving their DNA. Like your organs are not like independently
they evolve to benefit their host.
Yes,
the main.
And we have a ton of internal systems that regulate this. So like things that fight cancer cells, like the different immunosystem functions, all try to make sure that if anything is not serving the host, it gets killed. Like anything that is going against the host, there's this whole self-regulatory system in the body to make sure anything like that doesn't work. And so
again, this is all explained in the later chapter, Naked Warrior too.
Yeah, and that's one of the complaints I guess people were leveling against the book, is that the organization is kind of it repeats itself a lot.
Right, it repeats itself.
He talks about like a lot of this stuff in the early chapters, and then revisits it slightly in more detail later. And I think it could have done with some better organization.
I feel a bit like the chapter on sex, although it was pretty interesting, it kind of just comes out of nowhere into the book. It doesn't seem like it's organically part of the entire theory.
I think it's an aside for sure, but I definitely think it fits in with his theory that about the sort of the self-replicating things and working in an environment than being selected to replicate in a certain way. So I think it gives a fair enough hypothesis for why sexual.
Yeah, I can't put a finger on it either. It seems like a bunch of what ifs, but it's solid when you read.
Yeah,
I never thought of the problem of meiosis, or at least the occurrence of meiosis, being a conundrum in biology, but apparently it is.
And yeah, so it's not like he has a bunch of empirical data where we found early organisms that behave in this exact way, and we're talking about petri dishes. It's all just using basic statistics plus environment plus genetic replication and natural selection to try and make theories about how exactly these processes happened. So it's not. It's sort of like in a weird place between academic and pop science. So like he has all these different analogies in the book to try and you make these somewhat boring concepts about genetic codes and like battling proteins and self-replicators more appealing. But he also has like all this technical language and this sort of logical chains to describe different definitions for his replicators and stuff. So I would say it's a bit imbalanced in the sense that like it's not like firmly on the side of pop science. It's not firmly on the side of like this is an actual academic work that I want people to do research on. And I think you could definitely do research on what he explains if you're a biologist. But I don't think it's not sort of like a cleanly academic work. And I don't think it intends to be. But
I mean, I find that to fit perfectly with the new YouTube audience of people who get into
what?
Fucking push to talk, or get into subjects these deeper than I don't know. It's people have a very broad knowledge now that you can subsume.
There's the basic pop science stuff, and then there's the dabbling. I'm reading a few articles on things. I'm reading some books. I'm smart, which I guess where we are. And then there's the fall on academic autism. You get a grant. You cite all your stuff. You're basically working on an iota of an iota of an iota of a problem, and then you do your tiny contribution and repeat. And so we're in sort of a midpoint. And I always found the purely academic stuff has become inefficient in large part, just because of like the politics and the system stuff, but sort of the norms surrounding academia about like how you're supposed to do your work and your thinking. You don't want to think too broadly or too far ahead, or else your shit gets thrown out and people don't work on it. You gotta take your tiny steps. You gotta respect your elders, and that's just not efficient when you're talking about trying to really figure out what model,
get results.
What model fits the world the best. If that's your goal, then doing this tiny iteration, it's not that efficient, because more often than not, someone's going to make a giant leap anyways down the line, and then all your iteration, all the little tiny work you did for the iterations get thrown out anyways. So, yeah, I don't know. That's just an aside. Anyways, chapter 3, he talks more about sort of how all the organs in your body are phenotypic machines. That is, they serve to help DNA reproduce, and they don't themselves reproduce, even though they are part of the replicator itself. Like they're gears and cogs in the replicator machine. They're not they themselves replicators, and he just goes on about that. He says that the question of abiogenesis is pointless, and I completely agree with him. So he says that all right, so you could say, okay, so what caused abiogenesis? All right, well, if this amount of energy is implied to this chemical protein soup, then it will form like an RNA molecule, and that starts life. But then you have to explain, what process caused the proteins to form added from this energy? Oh, well, then you have to get in the quantum level, and you get to the quantum level, and you're like, these proteins formed because of this quantum process, but what explains that quantum process? So it doesn't really matter. Like you can say the why forever, and eventually you get back to, okay, why do all these quantum processes happen the way they do, and then why do we exist? So it doesn't matter. Like eventually you get metaphysics. It's not really a question to ask about, and it's sort of results in that. Okay, so like what do we actually know? Well, we know that there's these self-replicating proteins, and they existed in an environment, and the environment's about this old, and so then we try to fill it in from there using like all the data we have, all the archaeology, all the other stuff. And I think that's much fairer than trying to like say, oh well, you don't know how abiogenesis works. Well, yeah, of course not, because like you don't know why anything.
No one's going to know.
Yeah, like there's no one's going to know at the end of the day, anyways. Like it's like sort of a cause. He's sort of dismissing the causal origin, because at the end of the day, everything is from like whatever universal causal origin you choose to plug into your metaphysical model, and you're never going to know for sure. Anyways, he then sort of theorizes that this is from some other different like burgeoning theoretical work, that there's a sort of quantum Darwinism. That is to say that there's sort of quantum particles that behave according to a selection, a probabilistic selection methodology. And there's not very much work done on this, but there's different attempts to model quantum particles and their behavior based off these sort of environmental selection probabilities and stuff. And he says, oh well, there might be like a self-replicating thing that is in the quantum realm that led to the first proteins to form, which is sort of kind of harebrained. I think that's the most harebrained jump he makes.
I had never heard of it, and I have no desire to read about it. It seemed, I mean, it does not make much sense. But
I mean, it makes a little bit of sense. Like it's basically saying that there is our physics is determined by these quantum molecules. These quantum molecules behave according to a statistical distribution. That statistical distribution is shaped by a sort of microenvironment that has a selection process. And there is a sort of a particle. There are particles in that quantum area that follow the same rules as like self-replicators or trying to replicate themselves. And that's like fair, I guess, but I don't know.
Sounds like a big maybe, but yeah. I've never read any quantum science.
It's all, not bother. Yeah, it's all a bit weird. Shit just starts breaking down when you get to that tiny of a scale. All right, chapter 4. JF defends the theory. All right, so he goes over again, like what he already went over, which is the theory that RNA gave rise to DNA. So the sort of the idea is that we can't really figure out a way that RNA and DNA like independently just coexist, like came into the world together. It's not like there was an RNA plus DNA container that simultaneously had RNA and DNA form. One of them must have came before the other, and they're both similar. But then if we look at RNA, currently it's a bit simpler, it's less efficient, and it's been reduced to these tiny RNA viruses. That's basically all that's left of RNA life forms. And then he sort of uses that to extrapolate that DNA, which has a very similar structure of RNA, must have been a production of RNA. And I think that's fair. I mean, you could also figure that maybe DNA formed first anyways, and then RNA is some sort of mechanism from it. But you could, I think the presence of viruses sort of indicates that, which is, I think, the simplest form of life or pseudo life.
Well, we have the RNA within our cells as well, yeah. And then you even got the viruses who are in the DNA RNA tangle.
I think the simplest form of life that we see is RNA viruses, and so like in terms of like actual components and function, in terms of replicating itself, and so I guess you can make that as a logical conclusion that RNA came first, then DNA came along after. And then he uses that to sort of model the whole situation where RNA evolved DNA as an RNA factory, and then DNA evolved itself to make it more DNA factories instead of RNA factories. Anyways.
But to add to that, he kind of strengthens the argument as well later with the pointing out that the DNA seems to have come to existence like in parallel in several versions. You just talked about, what was it, the archaic and the
one of the
eukaryotes.
I guess the actual proof that he uses is that if you look at the process by which DNA reproduces, it relies on particular RNA ribosome molecules. In order for DNA to replicate itself, it relies on RNA to exist and be there. And so it'd be very weird for like DNA and RNA to just exist simultaneously, and for this reliance to be built in. He also talked. We were skipping a bit about, but this is also the chapter where he talks about the whole quantum Darwinism thing. I already kind of described the whole DNA RNA story earlier, and this is the story he, I think, is extrapolating on in this chapter. Chapter 5. All right, so RNA was a replicator on the Earth. Yeah, you get, now that reading back through my notes, he does repeat himself a ton. Oof.
Yeah, now he's just reiterating the whole process without the bullet points.
Yeah, now he's talking about the sort of the story in detail, which I already did again. So it's sort of the RNA formed out of proteins, and then RNA made a DNA. And the difference between RNA and DNA is only a couple of oxygen and hydrogen arrangements on the protein molecule. And so perhaps that happened. And then that DNA started producing more RNA that produced more RNA that could produce DNA more often. So that makes sense. He said the DNA could have served, besides just carrying its genetic material. So the DNA was produced, and it was just sort of this protein floating there, and it didn't reproduce itself. But it could, like, let's say you make a DNA, and then like an RNA virus is attacking you. Well, the DNA will like absorb it because there's all these peptides waiting there for the the virus to attach to, and then it will hit that instead of you, and then you can continue reproducing. So that's like an effect of this the early statistics of RNA and DNA interacting. And yeah, he just goes on to describe all these hypotheticals about like how the sort of environment and the ecosystem of early RNA and DNA proteins, just replicating themselves and being selected by statistics over time. Yeah. So that's where he talks about all the anthropomorphized struggle. Chapter 6, JF presents. All right, now he's talking more about memes again. He presents an argument from, I forgot her first name, but I think it was like a woman named Blackmore, who forwards that memes.
Susan Blackmore.
Yeah, Susan Blackmore, who forwards that memes control cognition and activity more than DNA in the current society. So he's trying to defend against this theory that memes now control us, that we're just living for memes, and we're just meme carriers instead of DNA carriers. And he just does this by, again, the basic premises that memes cannot survive without DNA carriers, nor can they replicate without DNA carriers, and the DNA carriers are free to modify them if it doesn't serve your purpose. So example, antinatalism is like the perfect example. So it's like, let's say you have a person who's an antinatalist, and then that person changes their mindset to no longer be an antinatalist, and they reproduce. Well, then the antinatalist meme just got owned and no longer replicates. So basically, memes are always subject to us because we always can modify them. And if they ever get in the way of our replication, we are free to modify them. Some people don't modify them. Some people choose suicidal memes. That does happen. But as statistics break down over time, there's going to be the non-suicidal memes are going to persist, and then the suicidal ones are going to die out. So basically, memes are not as strong as Blackmore or Dawkins asserts, is what JF's trying to get at. And here he invents some like silly words. He makes a word queen, which he's trying. I don't know why he makes all these words, to be honest. Do you know?
Yeah, that was my biggest. The cream plex too. The cream.
Yeah, he made like a word queen that describes like individual replication units, and then like queenplex to describe, it's just another word for environment. I just don't get like what he's going for. And there's some other reviews that complain about that as well. I think it was unnecessary to make these words. I don't think there was it was so obtuse of what he was getting at that he had to make these terms. All right. Chapter 7. JF describes how the physical individual cells in a multicellular DNA organism tend not to pass on any modifications. These cells, individually or collectively, what did I say? Face into genes. The cells themselves don't modify the genes and thus replicate. All right, yeah. So that was just where we're going once again, like just reiterating more and more. Your individual cells of your body don't replicate on their own. If they do, it's called cancer, and that's bad, and you might die. And your body has all these systems to stop that from happening. And it has all these DNA and these cells that go after that, and all these other systems that try to stop that from happening. So this is just more definitional stuff. He talks about how, like, for example, a hemoglobin cell does not make copies of themselves, and that for something to be considered a replicator, it must be able to print itself. And so none of your organs can print themselves. They're all reliant on DNA to provide the blueprint and the instructions to print itself. None of like if you culture like individual organ cells, they require additional things to print themselves. That's why you can't just like take somebody's like organ out and put it in like a primordial soup and have it like regrow. Like it needs a lot more going on than that. All right. So once again, you see, he's making more distinctions about the thing that replicates and the thing that and the tools it uses to replicate. So the DNA is the replicator. We are the DNA's tools, at least in these sort of these definitional terms about what a replicator is.
Yeah, the only part of this chapter that the replicator tango, when he starts going into that part, it kind of that's the only new stuff. Yeah, that adds to the
that all right. So basically, there's then a state. So you're a replicator, and you make different organs to help you replicate. But you could also make a entity that contains your genetics to help you replicate as well. So you can make a machine that replicates you that might also replicate. And then once that happens, if there's a machine that exists that physically holds your genetics and can like produce more of you and then potentially produce itself in any sort of arrangement, then you're in a what he calls replicator
tango.
Replicator tango.
Yeah, where the evolutionary incentives are split between the two replicators.
Yes. All right. So the basically then, if you're for example, a car is not in a revolutionary tango with us, but we replicate cars, and you might say, oh, are we just car replicators? But if I think the simplest example that sums it up is a cloning machine. So imagine we invent a cloning machine that can make more humans. So what if we made a cloning machine that made more humans that make more cloning machines? So eventually the cloning machine, if it has any ability to modify the genes of the human it makes, it's not like if it's like a human hitting a panel and there's nothing else, and it's just sort of inputting and outputting, then it's more like a human factory. But if the machine itself gets the capability to say, okay, well, it's more efficient in situation A, if I make a human with X, Y, Z genes, then it will start modifying its production until the cloning machine itself becomes the overall life form. And that's
essentially the entirety of the last chapter. Yeah. Is him playing out a fictive scenario of that sort.
Yeah. So basically,
I guess we'll get to that.
The big thing you want to be worried about is if there is some entity that stores your genetic information and could theoretically produce your offspring with it and modify your genetic information. So if you have those combinations, if something can produce you and modify your genetics, then it's a bad luck, because via the selection process, it may eventually start enslaving the entities it creates to create more of itself instead. All right, Chapter 8, JF talks about his naked warrior analogy. So, once again, it just makes more analogies, more
we already covered this.
We didn't. I guess we
it's
didn't
the
cover
fact that single cells can't survive on their own.
Yeah, single cells can't survive on their own. So, like, if you, he just keeps reiterating the point that without the tools,
and it feels like him trying to make filler chapters when he writes about this stuff in this detail. It
maybe I don't know. I like the yeah, it's a useful analogy. I mean, I don't blame him because he makes a variety of different approaches to reach the same idea. So if you're a different kind of reader and you prefer, like maybe when he was talking about the RNA and DNA having this sort of political battle, even though it's like it's a very goofy analogy for proteins in a statistical system, or maybe you like this naked warrior analogy where it's basically saying that if you have a soldier and he's trained to use spears, he'll be pretty good at using a spear and fighting, but if he has no spear, then he's not going to be able to fight and do his job. So basically, a thing without its tools can't do its job, is all it really means. As for why I use special new words for definitions, that's because all other words, like environment, have been poisoned by different meanings. I preferred starting from scratch. That's understandable, because you're right. Environments have sort of been attributed to all different kinds of things. All right, where were we?
I'd grant that point too.
Yeah.
The names are silly though. That's the thing.
The queen and the queenplex. I know, maybe it's just my naming sense is different, and I didn't really latch on to the word.
The trickster printer, because that's the next chapter.
Printer, I think the trickster printer is the most elegant one.
Yeah, that was thumbs up for that one.
So yeah, reiterating again, if someone cuts off your skin cells, it's not going to like form into its own skin blob organism and start self-replicating itself. Like that's sort of just what we're getting at once again and again. Like the things that you produce inadvertently while replicating are they themselves not replicators. But if the replicating entity can then be modified by things you produce, then that's when you get into trouble. All right. All right. Once again, Dawkins asserted that memes solve the problem of phenotype revolution, and now we are ruled by memes that jump from person to person. JF counters this by saying that memes both rely on host brains. Yeah, we went over that. All right, Chapter 9. Talks about how memes are not independent replicators, but called trickster printers. So yeah, so this is trickster printers, which is sort of the idea that if you're a thing that is being replicated by another thing, and you don't have control over your ultimate replication, then you're a sort of full replicator being printed by a trickster printer. And so there's different things that could be considered trickster printers, different things that be considered full replicators. But ultimately, what JF gets at is that memes are full replicators and we are trickster printers because we ultimately control the memes. I went over that a bit earlier as well. I liked one example was pretty good, was the consider two memes. So one meme is make moral babies, which was like basically saying K strategy. Raise your kids well, teach them a bunch of stuff. That's K selection. And then the other meme is make more babies, which is just have more kids. And in environment notwithstanding, I guess you could theorize environments in which the K selection actually ends up in the long run winning out. But just generally speaking, like the R selection meme will overtake the make moral babies meme, and then R selection will win, and the meme will die. So I think that sort of summed it up really well. When organisms enter a replicator tango, they both gain influence over each other, copying, and thus both occupy the distinction of being trickster printers. So yeah, so when something is in a replicator tangos, like when DNA and RNA, or say a human and a cloning machine, if they are in a replicator tango, then either one can modify each other. It's like the human can go in and say, oh, I don't like this cloning machine doing X, Y, or Z. I can modify this cloning machine. And then the cloning machine can also select in the other way, say, I don't like this human modifying me. I want this human to make more of me instead. And so that's sort of the replicator tangos, these two entities that reproduce themselves, modifying each other until one wins out in the environment. All right. Chapter 10, the last hurdle a phenotypic revolution must overcome after entering a replication tango is replacing the host printers. So this is sort of the idea. Oh no.
What now?
My chat's doesn't like JF. Although I guess that's to be expected, because way back when in the IBS days, my chat never liked JF too much. But it's all right book. The phenotypic revolution must overcome after entering a replication tango and having physical access to the genetic material of the replicator, replacing the host printer of their own printers. So if the printer can't ever replace you, then it's not a trouble. But if ever the sort of the entity that is printing you can then just print itself without you, like physically speaking, then it can fully take over. And he says that this sort of happened with DNA and RNA. And as more machines are made to replicate the host, the selection process will favor machines that can also self-replicate, and then eventually the machine will modify the output to replicate itself more instead of the host. So that's just the basic principle. If you make a machine that makes you, and that machine is subject to statistical selection processes, you'll eventually end up at a machine that makes you that self-replicates. Because if you want more of you, then you want a machine that can make more of itself, so it makes more of you. And eventually, under selection processes, that machine will start making more of itself instead. And that's just sort of the thrust of the book, described in a number of different analogies, a number of different ways of different phraseology. Okay. Yeah, he talks a bit more about the quantum replicator stuff. So, like the quantum replicating particle might have organized the proteins to start replicating. Like, let's say there's like a self-replicating quantum particle that is more present in the proteins that form the basis of RNA than in other stuff. And this is sort of, it all started with this quantum replicator. Although it's very unexplored, so I don't know if you could really say that's where you want to start. But it definitely, it's a good whack at it, because I guess it's a good whack at it because we know so little about quantum stuff that you could probably fit a lot of stuff down in there.
Nothing really better to explain it other than that.
And eventually we're going to get past quantum, and there's going to be like proto-quantum, and we'll be in the same situation. So it never ends with that kind of thing. And that's why I totally agree.
It's further down the rabbit hole.
Yeah, I totally agree when people complain about, oh, you don't know how abiogenesis works. Well, nobody's going to know. Like, who cares? Like it's like the same question as, oh, why'd the universe start? And you're never going to really know unless you're Spinoza's entity. And since nobody's Spinoza's entity.
I was about to mention Spinoza. Go ask Spinoza why.
Yeah.
He'll give you a long-winded answer.
Spinoza figured that shit out.
He defined it.
Yeah. All right, chapter 11, the sex chapter. So this is where he uses the same theory we talked about, so that if you make a machine that replicates you or helps you in some way that can replicate, it'll eventually outperform you. He uses that same theory.
This is a little different, though.
Yeah, it's a little bit different.
Yeah.
He's trying to describe why sexual reproduction started. And there's not really a agreed upon theory of like why things suddenly started, instead of just performing mitosis, started doing sexual reproduction. And the theory he comes up with is that the mitosis cells produced a half cell of sorts, like a cell that had half of the genetic material. And although this was a kind of a waste of like, resources and nutrition to make this half cell, the mitosis cell still benefited from it. So So if there was this half cell sitting around, then the populations of mitosis cells that had half cells were more successful than the populations of mitosis cells that did not have them. And so, like, imagine a single-celled organism, and then there's like it makes a deficient sterile half cell that can only reproduce if it had another half of genetics. And then that one fails, but there's like a few other, there's like, let's say 20 other mitosis cells sitting by it. If enough of these like half cells are produced, it'll form like a cushion. So there'll be like a group of fake, or not really fake, half cells sitting around the mitosis cells. And then like any RNA virus or any like environmental pressure, like it can absorb it. So they're basically using dead bodies as human shields. Would be a good analogy, I guess. So these
well, not even dead bodies, just using slaves.
Bodies. Yeah, like slave bodies.
Yeah.
So yeah, you take the mitosis cells made these half genetic cells that they were using as human shields, and eventually the human shields started replicating, and then they became better at replicating than the mitosis cells.
Specifically, they became capable of replicating by joining together because they were half cells, and then you have the two halves put together, and you have what is it? Mitosis.
Yeah. And I do like this explanation because it also explains why would there be like single-celled sexual tiny cell organisms, because like it doesn't explain why would there be those sorts of things. Well, it does, because like if you have that situation where you have these mitosis cells and then the meiosis cells, there's going to be leftover meiosis cell populations that will still survive and be subject to the selection process, and there'll be enough of a population that they can sustain themselves after this whole thing went on. So it also explains that, which I quite like. And then like an example of something that kind of follows this in biology is fungus. So fungus uses meiosis for their structural cells. So the different, like the stem and the spore head and all the other parts are done by sexual reproduction, and then the fungus itself, like the fungal genome, is produced by mitosis. And so I guess it's not only demonstrated sort of hypothetically, but with fungus. All right, and then chapter 12, which is sort of JF's point about the book, is the sort of the Pohl green text copy pasta story about what happens when we allow genetic modification and computer algorithms to interact with each other over a long period of time. And I guess I'll just read over the whole story. Why not? All right. So let's imagine a in vitro fertilization clinic that starts modifying the genes of its own customers. So like, let's say it's a clinic where if you're sterile, if you have problems reproducing, go to this clinic, and it says, oh, okay, well, by the way, while we do your IVP treatment, we can modify your kid's genes. And then let's say that happens, and then the people who were sterile, who had these modified kids, their kids become successful because obviously gene modifying lets you do some wacky shit that makes them more successful. And then not only is this encouraged because of that, but it's encouraged because different economic and political organizations would like that. So like, for example, insurance companies would love if people had less like disease, and so they'd probably pay you if you went and got like a gene modded baby, because if you're on your insurance policy and you have a gene modded kid, they're not going to be sick as much, and they can save money. And so they'd probably encourage it or even develop it. All right, so the gene modded babies originally just starts as a fringe to help people who were sterile, but as they became oh no, JF, why are you boomer posting? Sorry for violating.
Is JF actually posting?
Yeah, he is, but he says, sorry for violating your safe place. No. Snowflakes. I know. I can't. That phraseology, snowflakes. But yeah, sorry, JF. My chat really hates e-celebs. I have a running joke where all e-celebs are terrible and gotta go, and I myself am a terrible e-celeb and gotta go. It's just sort of the thing we do.
Yeah, don't worry about it.
Yeah, it's just
I don't mind. I watch your stuff every once in a while.
Well, yeah, they're just being tsundere, to use an anime term. So the gene modded babies that originally started as a fringe become more successful, and then I don't know, barking puppy. Oh, she'll be all right. The genes of the sterile parents remain, and so I imagine if you have these gene modded babies at these IPV clinics, that you're going to have it's going to be a lot harder to modify them back into like working order for their sexual organs. And I guess this is a contentious point, because if you're already able to modify your genes to the point where you can just make everything better, then probably, at least for a while, I don't think it would be at the start until that people would have poor reproductive capabilities. It would be a few generations in before that happened.
But he does bring up the point that it's most in the beginning it's mostly infertile people going through the process, and so you would be selecting for relatively infertile.
Yeah, but you would imagine that the infertile people, like let's say you're an infertile person and you're going through this and you have to bear this extra cost to have your kid modified, and you'd probably, if you put yourself in the shoes of that parent, they'd probably want their kid to be modified for more sexuality and more, better reproduction, so they don't have to suffer the same problems. At least that would be the meme starting out. I do agree that if then after that whole process, this gene modifying in vitro fertilization became popular, and then just gene modding in general became popular, then yes, reproduction would become less popular, and then people who were gene modded would focus on it less, even maybe foregoing it. But I think that becomes more of a political breakdown.
I mean, I guess it would make sense to have people modded to not be so obsessed with sex. It does really fill a whole lot in especially in developing brains once you get into puberty.
Yeah,
it's very distracting.
Well, I guess yes,
at least it was for me.
You could definitely argue that like the technocracy would have a huge incentive, and Abe says that there's an economic incentive for the clinic to suppress natural fertility genes. Yeah, there is. I don't think they.
Oh, that's it's
they
also
start
true.
out doing that, but I think more in general, the like the sort of technocracy, the Googles, the Apples, the people who rule us have an interest in making as good of a slave class as they can muster. So they would probably be pushing for this sort of thing, and also like inadvertently pushing for relying on gene modification over natural birth. Like that is a thing they can control. It's a thing they can modify themselves, and then they can ultimately use that to try and control the population.
And they can already push that stuff culturally as well.
Yeah,
just making stuff like natural reproduction not cool.
Just make it uncool.
Exactly.
Wow, you had kids the normal way. You're like a boomer. I guess that would eventually happen. All right, and so basically, as gene modding gets more popular, because obviously the kids who are gene modded are more successful in life because of the sort of a natural advantage they get. It would just basically be much more popular to have your kids in these gene modding clinics, and then eventually, to make your gene modding clinic more effective, you're going to make an algorithm. I mean, it's already going to be done by algorithms, but eventually you'd make an algorithm to modify the genes of your customers based off of the environment. So you say, okay, so the economy is not looking good for coders for the next 20 years, so we're going to change the person's genes to be good at something else besides coding.
Cricket farming.
We're going to make their I don't know. Cricket farming.
Well, that was just a reference to your own research.
Yeah. My dream of owning a cricket farm, but already if we have the technology to do this gene modding, we're already going to have like complex algorithmic models to try and determine like what genes are good and bad and how to modify them, and then eventually they're going to integrate that into like data systems to try and make it so like it reacts to the environment, into like what's socially popular. So if like elf ears are popular that year, then you'll have like an healthier kid, and so on. And so using this information, basically people will be being ruled by this popularity algorithm. Of course, individuals could probably opt to have different genes modified anyways. And I think that by the time like we have this technology in full swing, we'll already be going out into space, and so that might eliminate some of the total extinction concerns.
Yeah, see, that's exactly the point we got to as well when we were discussing a couple of friends of mine were. This is not a problem if we actually seed, the universe from here.
If we can get off the ground in terms of space travel, before we hit this break point until whatever the guy's name, John Q. In JF's story, there's a guy named John Q who starts spreading the. Basically, the computer makes an algorithmic genome, and that algorithmic genome is sort of like the optimal genome for that particular clinic.
Oh, he starts a chain of clinics. He's basically just he just corners the market, so to speak.
And he wants to spread his chain across the world to make as much money as possible. And so then you have like the different like optimal genomes competing, and then that might eventually turn into the genome machine taking us over. But if we could get off into space before then we'd be so distributed, just spatially speaking, that there would be like a nasty fucking automaton race on Earth who like eliminated genetic humanity, but there would still be genetic humans and their modified descendants throughout the universe in various states of like silicon and non-silicon life. So I think it's definitely a doomsday scenario, but I'd be surprised if we had like 4 generations of gene modded people and we still haven't developed space travel, then we're really fucked.
Right, because when we get into heavy gene modding,
because if we have heavy gene modding and we've got like 160 IQ Chads running around, and they're just just like inventing everything, and we still don't get space travel, then yeah, sure, this might happen. But basically, then the process is that the algorithm makes an efficient gene output, and then people start forming political organizations to spread their favorite gene output. And eventually the gene output that is the most successful at spreading itself becomes like the prevailing one, and then that one eventually selects to turn humans into biological slaves by changing subtly. Like it could do it subtly over a number of generations, which is why it's like pretty spooky. So like the algorithm could change it. So okay, let's make this person more, and I could already see like the company doing this. Like if you have a person who's gene modded, and then you have a gene that would make them like statistically more likely to like gene modding and gene modded kids, and you turn that gene on, then over time it's going to keep selecting until like everyone loves gene modding, and then you can then select a subset of that, which is everyone loves this particular gene modded algorithm that's dominating, and then it changes your genes to make you love that, and so on and so forth, until you just have everyone serving the sort of
incentive cycle that feeds itself. It's really
You need political action restricting gene modding after it's already universal. I don't know like how fast and of an upswing gene modding would really end up being, though. Like I could imagine within I don't know if it would be 4 generations. I think it would take longer, because there's so much institutions that would go against it for a while, and different political factions. I think it definitely wouldn't just go quietly. It wouldn't just be like the new iPhone, the new gene mod. I don't think everyone's down with gene modding, at least culturally. Maybe that's what the elite's goal is to make everyone so degenerate that gene modding sounds great.
I mean, personally, from the amount of pushback I hear from people, even just taking DNA tests, it seems unlikely that, like you said, 3 to 4 generations is possible. I think people are going to be more weary.
Like already, we have people complaining about stem cell research. Fucking gene modding.
Right, that too.
Yeah, gene modding is going to mobilize whole groups of political opportunists. So it's going to be a bit of a rockier road. But I could definitely see this eventually happening. I just don't know if the timeline lines up with technology to such a point where it would extinct us and we wouldn't get the space or do some other stuff. So I don't know.
But his idea of extinction does pan out over thousands of years.
Yeah, actually almost millions of years for the end part where we all become.
Oh yeah, the end part. Yeah.
Yeah. All right.
So definitely over thousands of years.
So under this model of this sort of corporate genetic modification corpus, the algorithm then tries to make people who spread gene modding instead of spreading themselves, and it'll, in order to encourage more gene modding, it'll favor people being sterile. So eventually, in a situation where we don't leave the planet and we're not distributed, and we have gene modding, it'll probably be to where everyone is basically sterile at birth and encouraged to gene mod. Not only because this gives the technocracy additional control over your life, but because the gene modding companies and the sort of the gene modding algorithm itself would favor this. And so there would be a point where we're all basically sterile and getting gene modded, and we just see that as normal. And then there's a turning where the gene modding algorithm starts changing us to be like completely servile to it instead.
Yeah, he uses the term Frankenstein. It's basically going to be very, very, very specialized organisms.
We start turning into all sorts of nasty things, and it would be too late because we'd all be conditioned over it could basically figure out, get like a little bit of objective awareness. It could like analyze the data that says, okay, people would react violently if we did it this quickly. And so in the next 10 generations, we're going to implement a gene change until everyone's a slave. And so like a 10 generation countdown, everyone's a slave. And it could definitely do that. Like that is definitely doable for like an algorithm that's self-correcting like that. All right.
That's the hardest thing to convince other people of when talking of this theory has been the idea that we're going to become completely sterile.
Completely sterile.
Although I don't see it as a complete no. It seems plausible because if you had a system that was more efficient, you could bring plenty of arguments to the table as to making people being sterile a better outcome for the system.
Well, I think it would be a better outcome for the elite, so it might happen. And there would definitely be numerous holdouts. There'd be religious holdouts. There'd be people who want to go live in the woods and like compounds and stuff as naturals. But I agree they would end up on the political margin, and sort of the norm, the corporate produced people would end up being sort of these sterile gene modding based Zoomers. Well, I guess it would be way past Zoomers at that point, though. All right, what was the other point I was going to make? I could see that the elite themselves would have like their own gene modding for a while, and would they get subsumed by the algorithm? Maybe. That's an easy one. As long as people who are modified are more efficient, more sexy, more in vogue than those who can still reproduce naturally are being selected against. You're right, and that's already kind of happened, I suppose, because if you look at our current society, we're selecting for people who are good at going to a job every day, and not for people who like say go like farm on the land or hunt or anything like that. And so
now we hear Kaczynski talking.
Yeah, Kaczynski talking, but Kaczynski's right. Like if you look at the man now,
he's right.
Before, our population's already been warped and selected into the system where like we're almost incapable of doing that now. And so I could see you're right that people might be more efficient, more sexy, more in vogue, and that might end up being ubiquitous over time. But overall, I think it does depend on political factions, and if I would think more often that the elite would have their own genetic modifications, and then they would sort of, the people who run the clinics and are like the super capitalists would have like super modifications, and then they'd push like consumer grade plebeian modifications onto people. And I think it would still be stratified like that. And if that stratification stuck, then maybe the elite would be able to curate it in such a way that it would avoid like a total extinction event. I mean, they might turn us into like Brave New World. We're all like amalgam slaves to the super gene modded elite. That's sort of the meme, right? Like the the cyborg gene modded Jewish elite that rules over us in the next 20 years.
Can only hope.
Yeah.
Holy shit. I haven't read Brave New World, though, so I can't talk to it.
Gains through random mutation versus the value sum of all genetic knowledge held through the algorithm. Chances of making gains. Yeah. Some genetic knowledge held by the algorithm. So you're saying that the ultimate algorithmic optimization that it makes by analyzing every gene output in relation to the environment versus like the success of mutation. Like let's say the people who have mutations end up as a whole being more selective than the people who are the optimally selected by like algorithm. And the thing is, like, I can kind of see it, but
in that case the algorithm is wrong.
Yeah, like the algorithm can be wrong. And this is kind of a weird analogy. This is a weird analogy, but hear me out. Think about card game metagames. So in card games, in card games, people play different decks, and usually, like, there's a deck that becomes optimal. It's like it becomes the standard best deck, and so everyone's playing this great deck, and then somebody develops a counter to this deck, like something that is specifically engineered, like to every iota, the counter to this deck, and then they play that and they beat the meta. And then there's something that gets developed to defeat the deck that beat the meta deck, and so on and so forth. And that leads to like this sort of rock paper scissors, or even deeper than that, many levels deeper than that, where you have these competing different arrangements. And so I don't think it would end up in a monoculture. There would definitely be, if you've read a fun science fiction book, JF, you might not have, but Neil Stephenson's 7 Eves, where he comes up with this interesting idea about people breaking into 7 races after we get eliminated down to 7 people in a space station. That these
Don't
races
spoil too much of that, yeah. But yeah, keep going. I want to read that one. I stopped listening to the review because it sounded good.
Read it; it's really good. Irrespective of a good mutation, finding another good mutation, find a sexual partner, mate with the algorithm, which has a list of all good mutations. Yeah, but here's the thing, JF. It's going to be there'll be a gene set A that will be the most popular gene set, and then there'll be gene set B developed to beat gene set A, and then there'll be like hybrids and it'll just be like this weird like gene modded like racial battle, and it'll be like an arms race. I don't think there'll ever be like an end to the gene arms race. So it'll be like a metagame. It'll be a sort of gene population metagame for success as people try to run counter. Like, so imagine a gene modded person who is part of set B who's able to like psychologically dominate a gene modded person in set A, and then like convince them to mod their kids set B, and so on and so forth. And so you'd have this constant battle of these different arrangements that are trying to snipe each other in sort of the reproductive competition.
Isn't the main question just here is whether or not a monopoly can arise from this? And I would say that it is monopolies
you don't even need a monopoly. Well, I guess you do need a monopoly, because if you don't have a monopoly, then like let's say China. I mean,
that's at least the John Q scenario is a monopoly scenario.
Absolutely, but this metagame, there is no place for natural reproduction. Algorithm gives you full access to any new mutation found to be good. You can copy the naturals. Yeah, I agree with you, JF, that the natural reproduction at this point would definitely, when there's this genetic gene mod metagame, would definitely fall away. But there would be people, like individuals would be like memeing, would they be influenced by memes, unironically, to like join a team in a gene mod metagame. Like maybe they see like the gene metagame is like, oh, everyone is in the last couple of years is going, let's develop a counter gene set. Because people the people making in the clinics can still like make fine-tuned modifications, and so you would have gene engineering where you're trying to engineer a person who's like built, like every aspect of them is built to dominate and outcompete another specific person, not just like people in general, but like a specific person. So like how parasites in biology evolved to target specific things. And I think there would be much more vigorous competition than maybe you let on. What if the AI just acted like a dating service? It just pairs humans of superior genes. Yeah, and I think another point I guess to bring up is that you'd also have to assume that people would abandon traditional birth altogether, or at least the time frame in which they abandon traditional birth. Because if they ever, because you can't have the revolution if you still have. Well, you could. Maybe, I don't know. Could you? Could you have a revolution if people still, if they're still getting implanted in embryos in women's stomachs?
I think you could. It's not just like the fact that he mentioned AI. It's not necessarily AI. It's
the psychology could still be warped.
System at large.
Yeah, the psychology could still be warped in such a way to lead to the phenotypic revolution, even if the children were still being physically made in the humans in wombs.
Right. I mean, the only question of whether or not you wouldn't use humans to give birth to more humans is, could you make a system that would be more? That's just, we just don't know.
Yeah. I don't know. I think it definitely raises a lot of interesting questions in terms of thinking about the implications of gene mining. I don't know if this apocalypse would happen as described. You can complete the revolution with some sort of looms, just like DNA. Yeah, I agree, JF. Like they could modify the people could be modified so that they like start willingly becoming like slaves to producing a more gene modification algorithm clinics or whatever, and they don't care that their wombs are being used to produce slaves. They don't, because they're modified to like that. It doesn't matter. So yeah, I understand that, but I'm thinking that because of just how competition among intelligent beings works, it's different than sort of long-term statistical processes. Like competition between civilizational humans is a lot different than just sort of natural selection. Like social Darwinism isn't really a great theory to explain like success of civilizations, because it's based more on like ingenuity and countering and like game theory than it is, say, like pure statistical selection. And so what I think is, I guess one counter is just that there would be this intense sort of genetic modification competition metagame in which like different nations, different groups, different types of people would be modifying themselves to like battle each other, or maybe not even like violently, but just sort of like in a sort of a marketplace and there would be a constant threat of like they'd have to develop defenses against it. Computers will have plenty of moves in advance. They don't have a problem planning in advance of chess. If you found out that you could have an IRL waifu that
oh man, I wish I could read chat. That sounds good.
That bug behind you says, if you found out that you could have an IRL waifu that you could artificially impregnate, why the fuck would you pick real reproduction? Genetically modified cat girls for slave ownership. Is that what you're saying, bug behind you? Come on. We all know that's a libertarian pipe dream.
But if I'm getting this right, Jeff, you're really just proposing that the battle would be endless. No one is going to win.
I would say
the genetic race.
Well, no, I think there might be eventually a dominant genetic algorithm on the planet that then turns people into slaves, but that would be delayed significantly because there would be competing people gene engineering metagames to defeat each other specifically.
So we're just talking a difference in time scale, because I don't even know how long the John Q's.
I think people, and that's sort of what I was getting at with the DNA-based humans will lose all of them. I think maybe eventually, JF. What I'm saying is, I don't think it would be as sort of clean as what you described, is where it's just sort of like very quickly is subsumed into this one phenotype. I think there'd be intense competition for a long time. And the reason I brought up card metagames is that we have a lot of data for card metagames, these games people play competitively, and that they win real money playing. and they develop all these statistical models and stuff to try to predict things. But ultimately, it's the person who solves it. It's ultimately a person who solves it. Until we develop like super advanced computers that were able to solve these sorts of problems that we can't solve, then I don't think it's really a concern, because we can't even solve simple mathematic card games. Like they get broken by people just innovating and coming up with different combinations of decks that defeat metas.
My issue with that argument is that that's really just a battle of memes, where that doesn't touch reproduction. In the case of this gene war, it's the better ones are going to replace the ones who aren't. So it's
but that's what I mean. Like
fundamentally different. But I understand the analogy. But
well, I mean, we still live in a society, gangweed, and so in the society there would be like, say, gene. Like as I said earlier, Jeff, Google DeepMind can play StarCraft 2 professional level. The AI is already beating us at Vidya. Yeah, I mean, but that's it's still pretty limited. Especially for a game like StarCraft. Like, StarCraft's very mathematic game. Game theory is correct, but you're continually introducing new cards. Yeah. And you not only would all of genetic modifications and their expressions have to be figured out, you'd also have to account for like cybernetic modification, which I'm sure at this point would be occurring down the line. Like once you have 160 IQ gene modded people, they're going to develop like super cybernetics, and then maybe gene modding becomes less of a concern. And maybe the people, and it becomes a whole super complex system, and it still becomes a metagame, like similar to how nations interact. It's not really up to Darwinism. I think people will continue reproducing naturally as a way to show status, or just try to show their offspring is better. I mean, yeah, there definitely, until like there would be like some sort of tyrannical state crackdown on natural people by like the hordes of gene modded babbies. Then there'd always be a population of natural people until like whenever that Holocaust occurs. But I don't know how deep down the timeline that would be. Yeah, and so just kind of like all futurology, it's more complex than it first appears. But I think it's a good concept to think about, and it's definitely a risk, not only with gene modding but other technologies as well. Signaling liberals save the human race. Ironically, Abe, I've been thinking about how like although the libcucks are just trying to be trendy with their environmentalism and like organics and natural, they're actually going in an okay direction, even though they're doing it for all the wrong reasons. Then it'll be like the oblongs, but artificial people, but versus real people. Yeah, there'd be like cyborgs and robots and other shit fighting these gene modded people, and it would just be very complex.
It'd be like Deus Ex.
Yeah, it'd be like Deus Ex. And the more complex these systems becomes, the harder they are to really control top down as well. So I don't know. I think it's complex. I just think that definitely if there was this sort of situation where a sort of meta of a gene modded that is considered optimal is developed, it would not just like then take over and then have the end of humanity. It would be competed against by people who make a specific engineered counter to that optimum gene output to dominate it psychologically, and I guess sexually too, in order to out reproduce it. And I think that would continue for quite some time. You don't believe it'll be like Deus Ex. It'll be like the oblongs. Environmentalism is anti-natalist gang. How can you betray humanity, Jeff? You mean Mega Man? As long as we get to live in a Blade Runner or Blame type dystopian future. Isn't that sad, Channel? Like that the dystopian futures are like way cooler than the dystopia we live in? I hate that. It sucks. The current dystopia is just so boring. Fucking Google is so lame. You don't even get like cyber AI waifus. Come on. All right, well, I guess I'll go for about 5 more minutes. We basically discussed the whole thing, and we had an interesting discussion about
It's only the last supplementary predictions. I only skimmed through them.
Yeah, I skimmed through them as well. but I quite liked the explanations for the DNA and RNA stuff. That was pretty on point for a realistic explanation. Of course, it's going to need more actual laboratory study, and hopefully this book encourages some of that. That'd be great. That would prove that you don't really need to go for the stuffy, crappy academic system.
Unlikely though. JF has become kind of a black sheep.
Yeah.
In a sense, which is sad. But I like the chapter on sex. That was I had never considered that step from mitosis to meiosis.
Meiosis is a difficult step to make. I mean, there's a lot of difficult steps in evolution that people were working on, but that's one of them.
So that was interesting.
Yeah. And I think the overall dystopian thing, it's pretty good to think about. And I think definitely people should be completely cautious of gene modding. And not only just for the total doomsday scenario, the phenotypic revolution that JF talks about, but just because if you have gene modding, then Mark Zuckerberg is going to be probably modifying your genes to be like a Facebook drone or something. Just on a basic level in our current society, it's already bad. Like the people who provide it are going to just be trying to control you. It just sort of centralization plus technology is bad. If you could have decentralized good technology, that's good. So the less people involved if your technology is the better. Gene modding is the ultimate form of cucking yourself. We need to make us immune to all sickness, diseases, and parasites. Yeah. There's another thing I wanted to talk about, but I guess I'll hold off. Maybe I'll make a video on it or something. I wanted to talk about how maybe genes aren't the most important vector for fitness, or something like that. Maybe
what else would be then?
It's not how much you remake yourself, because the more you remake yourself, the more you change over time. It's how little you change over a period of time while still existing, I think. So would you say that an immortal person is more survival fit than a line of people?
That's a good question.
An immortal person. Say I'm a black sheep, have an audience size. Well, we're referring, JF, to your relationship with academia and colleges. I assume, JF, that if you went
it was no poop flinging.
Yeah, we're not saying that you're unpopular. We're saying that if you went into say a random university and they Googled you, they probably hate you, just like they hate anyone mildly associated with any politics that isn't gay weed Lamau.
Right. We're not going to be kvetching at you. Don't worry.
Jeff cucking to the East-Lab? Well, no, he just didn't understand what we said, Ken. Sadly. Is it possible that gene editing can make us immortal? Yeah, that's what I'm talking about. It's I think immortality kind of throws a wrench in some stuff too. I was kidding. Truth will prevail. No biologist can ignore the truths in this book. Yeah, I definitely think
I'll give you that. Because Dawkins haven't commented on it, has he? At least last time I heard from JF. I'm looking very forward to that.
Diogenes comes into the chat to shit post about nonsense.
Oh no.
Some guy.
Yeah, he's just some guy.
Some guy.
I already cried once.
Cryogenes. That field one biologist already discarded the truths for grant money. Yeah, I think definitely a lot of the stuff it talks about, the RNA DNA origination stuff, the selection process, the meiosis stuff, they should definitely work on that. Do some lab studies, some cultures to try to figure that stuff out. And yeah, I think the futurology edition is also interesting to think about. I don't totally agree with it, but I think it's definitely a risk that it's a potential apocalypse of the thousands of potential apocalypses there are. All right. Gone for about 90 minutes. Anything you want to say, Mo?
No, not really. I just boringly agree as always. Not always, but it's the futurology, like you said, it's a good hypothetical. I don't completely agree with but it's hard to poke holes at it. from a logical perspective.
Yeah, it doesn't make any huge leaps. I would say the largest leap it makes is the quantum stuff, because we know so little about it. But it's not. That's basically just saying.
Yeah, the quantum stuff, exactly. Yeah.
But that's not even that huge of a leap. It's just saying that maybe there's selection processes in physics that might be considered replicatable or replicators. Yeah. All right.
Well, then that's it.
That's it. We're gonna try to read American Psycho for next weekend, which will be fun. I don't know if Mo here will be able to finish in time. I also had another person who wanted to read it. We'll see if they are down for next weekend. I'm gonna reread it and have fun with that. It's a good book. And I don't know where we go from there. IBS or so 2018. Nice job, Dio. You pulled an Andy. Oh no. All right. Thanks for watching. Go enjoy your IBS drama streams, I guess. The comfy book stream is over. Thanks for tuning in.